Hello there, fifth graders, and welcome to this lesson where I go over the Chapter 2 practice test with you. Okay, so the first one says, oh, and notice that I have the test over here on the left and I have my scratch paper over here on the right. If you're doing this test with me, make sure that you put everything on your scratch paper that I write on my scratch paper. Do all the problems with me. Don't just wait until I tell you what the answer is. Make sure you're doing it with me. Okay. The first one, this is a number obtained by raising a base to an exponent. And it's either compatible numbers, power, product, or factor. Now, the answer here is power. A power is a number obtained by raising a base number to an exponent. And so I said to use your scratch paper, but obviously for the vocab questions, there's nothing to put on your scratch paper. The next one is vocab question 2. It says, this property states that to multiply a number by a sum, you can multiply each addend by the number and add the products. And it's either exponent, base, distributive property, or power of 10. And it's distributive property. That's the property that says, like, 3 times 23 is the same as 3 times 20 plus 3 times 3. Next, this is another vocab question. This is a number that divides into a whole number evenly. It is also a number that is multiplied by another number, and the answer is factor. Like the factors of 8 are 1, 2, 4, and 8, because 1, 2, 4, and 8 can all divide evenly into 8. They're also all the numbers you can multiply together in order to equal 8, like 1 times 8 is 8 and 2 times 4 is 8. Next, blank. Not blank. This is a way of expressing a composite number as a product of its prime factors, and it's either distributive property, compatible numbers, power, or prime factorization. Remember, prime factorization is the way of expressing a composite number as the product of its prime factors. So, for instance, the prime factorization of 9 would be 3 times 3, because 3 is a prime number, and it's also a factor of 9, and 3 times 3 equals 9. Next, this is a number like 10, 100, 1000, and so on. It is the result of using only 10 as a factor. It's either exponent, power of 10, base, or factor, and it's power of 10. Remember that a power of 10 is any number like 10, 100, 1000, 10,000, 100,000, a million, and so on. Any number that starts with a 1 and then has only zeros. And then these are numbers that are easy to multiply mentally, and it's either power, product, compatible numbers, or exponent. And remember, the answer is compatible numbers, because the word compatible just means that two things get along well. So compatible numbers are numbers that get along well inside your head. They're easy to add, subtract, multiply, or divide. And then the next one, this is the answer to a multiplication problem. It's either product, factor, power of 10, or base. The product is the answer to a multiplication problem. When you're multiplying numbers, the two numbers you multiply together are called factors, and the answer is called a product. So it's factor times factor equals product. And then there's a couple more vocab questions. In a power, this number represents the number of times the base is used as a factor. So for instance, in 3 to the second power, or 3 squared, the number that tells you how many times to multiply 3 by itself is the 2. So 3 to the second power, or 3 squared, would be 3 times 3. And then in a power, this is the number used as the repeated factor. That's the base. So in that last example, 3 to the second power, or 3 squared, the number that you multiply by itself, the 3, that's the base. Okay, here's where we're going to start using our scratch paper. It says find the prime factorization of 16. Remember, to find the prime factorization of a number, you start by writing that number. Then you make a factor tree, which means that number sprouts branches. And what grows on the end of those branches? Any two numbers that can be multiplied together to equal that number. So the two numbers you can't choose are 1 and the number itself. So even though 1 times 16 equals 16, I can't write 1 times 16. But I can write any other numbers that can be multiplied together to equal 16. Like I could choose 4 and 4, because 4 times 4 equals 16. I also could have chosen 2 times 8. Then 4 and 4, since neither of them are prime, they both sprout branches. And 2 times 2 equals 4. 2 times 2 equals 4. Now these are all prime numbers. 2 is a prime number because nothing equals 2 except for 1 times 2. That makes it prime. And then the prime factorization of 16 is just all these prime numbers. I just multiply them all together. So 2 times 2 times 2 times 2. And 2 times 2 is 4, times 2 is 8, times 2 is 16. So since 2 times 2 times 2 times 2 equals 16, and since 2 is a prime number, all these 2's are prime numbers because they're all 2. Since they're all prime and since they equal 16, that's the prime factorization of 16. Now go ahead and box that work off. That's the work we did for that question. You want to be able to find the work you did for each question, so it's good to box it off to keep it separate. Now, moving back here, it says find the prime factorization of 54. So go ahead and write 54. Now, what happens next? 54 sprouts branches. And now on the end of those branches, we put any two numbers that can be multiplied together to equal 54, like 6 times 9 equals 54. Neither 6 or 9 are prime numbers, so they both sprout branches because they're both composite. And then 2 times 3 equals 6, and 3 times 3 equals 9. And 2, 3, 3, and 3 are all prime numbers, so that's when you're finished. Once all the numbers at the bottom of the tree are all prime, and the tree can't sprout any more branches. And then you just multiply all those numbers together. 2 times 3 times 3 times 3. And 2 times 3 is 6, times 3 is 18, times 3 is 54. So since 2 times 3 times 3 times 3 equals 54, and since these are all prime numbers, this is the prime factorization of 54. Go ahead and box off that work, and let's do the next one. It says, how would you write the following exponent using repeated multiplication? And it says 10 to the second power. And the other way we say that is 10 squared. Because remember, anytime a number is raised to the second power, we say it's squared. And anytime it's raised to the third power, we say it's cubed. So 10 to the second power, 10 is the base, 2 is the exponent. The base shows you which number to multiply. The exponent tells you how many times to multiply that number. So 10 to the second power just means 10 used as a factor or multiplied by itself twice. So there's two 10s multiplied by each other. So 10 to the second power means 10 times 10. Okay? Next, how would you write the following exponent using repeated multiplication? And it's 5 to the fourth power. So 5 is the base, so that's the number we multiply by itself. 4 is the exponent. That tells us how many times to multiply 5 by itself. So 5 to the fourth power just means 5 times 5 times 5 times 5. See? 4 5s because it's 5 raised to the fourth power. Make sense? Hopefully it does. Okay, the next one says 73 times 100. And look, you can just write it like this, 73 times 100, the exact same way it's written here on the test. And then just do 73 times 1, that's 73. And then take these two zeros, there's two zeros in the factors, so add two zeros into the product. And the answer is 7,300. Okay, let's box that one off. Next we have 70 times 50. And all you have to do is 7 times 5. And 7 times 5 is 35. There's 1, 2 zeros in both factors, so add 1, 2 zeros into the product, and it's 3,500. Go ahead and box that work off. Next it says estimate by rounding both factors before multiplying. So let's write 72 times 36. Now, we're not finding the exact answer here. It says to estimate by rounding. When you're estimating, you're finding an answer around the exact answer. So we're going to round both of these numbers to the tens place. Rounding them to the tens place means the digit in the tens place is the one asking for a raise. So this 7 is asking for a raise, and it's asking the number to its right. So it's asking the 2. So the 7 says to the 2, hey 2, can I have a raise? But remember, only 5 or more can actually give raises. 4, 3, 2, 1, and 0, they can't give raises. So the 2 says no. And you can remember that by thinking 5 or more, up the score, 4 or less, let it rest. So 2 is 4 or less, so you let it rest. The 7 stays the same. And everything to the right, like the 2, becomes a 0. Another way of thinking of that is, since 72 is closer to 70 than it is to 80, it rounds down to 70. Now here the 3 is asking for a raise. The 3 asks the 6, and the 6 says yes, because it's 5 or more. So 5 or more, up the score. So the 3 goes up, it becomes a 4, everything to the right becomes a 0. And again, another way of thinking of that is, since 36 is closer to 40 than it is to 30, it rounds up to 40. Now we multiply 70 times 40, and all we have to do is 7 times 4, that's 28. And then 1, 2 zeros in the factors, 1, 2 zeros in the product, 2,800. So it's this one here. Now that's not the exact answer. That's not the actual answer to 72 times 36. It's an answer that's around the exact answer. It's an estimate. Okay, which shows 8 times 71 solved with the distributive property? Remember that a great way to show the distributive property is with an area model. So let's make our rectangle here. And then we're going to separate it into 2 parts, a little part and a big part. The big part represents 70, the little part represents 1, and then the 8 goes right here. Now we do the answer to 8 times 70 in this big box. 8 times 7 is 56, and then we add the 0. Elena, would you mind propping open that door? 8 times 7 is 56, and then we add that 0 from the factor into the product, and then 8 times 1 is 8. And then 560 plus 8 is 568. And then another way of showing that is with an expression. See, 8 times 70, 8 times 70, plus 8 times 1, 8 times 1. So which of these shows that same thing? Well, this one says 8 times 70 times 8 times 1. That's not right, because it's supposed to be 8 times 70 plus 8 times 1. This one says 8 plus 70 times 8 plus 1. That's not right. This one says 8 times 70 plus 8 times 1. That's the same thing we have here. 8 times 70 plus 8 times 1. And it has the correct answer too, 568. This one has the right answer, but it doesn't show the distributive property, whereas this one does. Okay, just a couple questions left. This next one says 23 times 6. And it doesn't tell you how to solve it, so we'll just use the standard algorithm. 6 times 3 is 18. We carry the 1. And then 6 times 2 is 12, plus 1 is 13. So the answer should be 138. Hopefully you're following along and writing everything Mr. Dauber's writing. The next one says 56 times 24. This is a 2-digit number by a 2-digit number. So we start by multiplying the ones place on bottom by the ones place on top. 4 times 6 is 24. Then we do the ones place on bottom by the tens place on top. 4 times 5 is 20, plus 2 is 22. Then, really important, you have to erase what you carried. Thank you, Mrs. Fawning, for that whiteout. And then you have to add your placeholder. Then you do 2 times 6, that's 12. 2 times 5 is 10, plus 1 is 11. And then we just add those two partial products together. 4 plus 0 is 4, 2 plus 2 is 4, 2 plus 1 is 3, and 1 plus nothing is 1, so the answer is 1,344. Now look at Mr. Dauber's scratch paper here. Look at how much work I did. I filled up the entire page. If you did this practice test with me, your piece of scratch paper should look the same. Hopefully you did all the work with me. Hopefully you have a nice full piece of scratch paper, and hopefully it's all nice and neat and organized too. If you did this practice test with me, you can go ahead and press submit and get a 100%. I will catch you next time. Signing off, Mr. Dauber. Bye now.